So, guys, today we are going to discuss about this topic called CNN, RNN, Recurrent Neural Network. Recurrent Neural Network. This is very important, perhaps considered the beginning of time series based neural network models, using which we can deal with complicated kind of data, such as text data, images, and so on. So, this is time series based neural network, time series based artificial neural network. Every neural network is a type of ANN only, artificial neural network, right? Even CNN is a type of ANN, correct? So there are many types of artificial neural network. We know multi-layer perceptron, we have learned that's nothing but basic artificial neural network, or also called as a deep learning model, when there are many hidden layers. CNN is also a type of ANN, and it is also a deep learning model because we will have more than one hidden layer. Like that, RNN is also a type of artificial neural network. We also have other types such as LSTM and GRU. When we know this, we can understand this and this, because these are nothing but simply the extensions of these two. These two models are extensions of this RNN model. Okay. And I'm saying that CNN is particularly to deal with images, mostly. I will just write here mostly for images. And RNN is mostly for text, but you can use it on other data also, such as images or numerical data, tabular data, anywhere you can use it. Okay, so this is mostly for tabular data. Right. So these are all the basic understandings, right? And in the previous class, we have also seen about some time series based models. We understood the importance of time series, right? Time series or time dependency. And we have seen when, in which cases, time is an important factor. So we have discussed some use cases, some situations. Can you tell me what are those situations? Do you remember, or can you think now and tell me? Which situations? Any examples where time is important, time series, time dependency should be captured?
The share price forecasting, so many forecasters are there, right?
Yeah, yeah. So tell me some examples. Stock price prediction.
Weather prediction.
Yes, weather prediction. Okay. And examples where time dependency is not there. So that will be usually when we look at multiple products prices. For example, this is product one, location, uh, number of items.
It means like more number of interdependencies, right?
Yeah, yeah. Price 100, 105, 300. And then there is also A, C, B, something like this. Okay, so to know the price of this, let's say, it doesn't depend upon these prices. We have to consider the location, and then the product category, let's say, category and everything we have to consider. Category we definitely have to consider. Location we have to consider. Number of items available you have to consider to be able to predict what could be the price of this product. But price of these products has nothing to do with prediction of this. Right. So this is an example where time is not important to consider. But if I'm dealing with the same product, then yes, definitely maybe. So let's say product is Microsoft's price, on this particular date, 11, 12, 13, like this, Microsoft. All are for Microsoft. And price is 300, 305, 302. And to predict on 14th, definitely it'll be either 5-6% up or minus from the previous value. So it depends upon all of the previous values. See, 1 week previous value, 10 days previous value, 2 weeks previous value, and so on. So here it is important to capture the previous values, previous price values of this Microsoft itself. Okay, that is y depends upon the previous y values, yt over here I can write. This is yt depends upon yt minus 1, yt minus 2, yt minus 3. But over here, that's not the situation. Here, yt depends upon x1, x2, x3, x4. It doesn't depend upon product name, so I don't have to worry. Yt depends upon x1, x2, no, x3, x4, like this. Okay, this is a basic difference. Okay, so now let us go further and know more details about RNN. This is very important, so I will go a bit slowly. Okay, first we will understand the architecture, and then we will first look at some examples, text-based examples. Okay, and then we will see architecture. Uh, and then we also have to see this one, which is backward propagation, forward and backward propagation. It's called as backward propagation to time. So we will see this. And lastly, we will see the code implementation. Okay, this is what we have to see, guys. And before we start this, let me quickly show you the CNN output as well, just a few minutes, so that we will completely finish everything with respect to CNN. So I will be reading the data here. I have taken the data into my folder location in this Google Colab, and I have read the data using pandas. Okay, you can see there are total 86 records being read in the train data, right, X train. 2000 are there in Y, but it's okay. We can deal with only 86 records. We will filter it later. Fine. So now let's proceed. X train is like this. I can divide each and every number by 255 as we have discussed before. So now X train is like this. So I have normalized the data. Okay, so that there won't be any bigger impact, there won't be any impact of bigger values and smaller values and so on. Okay, and then I am reshaping my data, because we know that in CNN it is actually not a linear kind of an operation we will be doing. We will be doing convolution operation of filter on the entire image in a spatial manner. That is like this. This is the image. We will search like this, right? So we need the image to be as an input given in n cross n dimension. And if it is a RGB, then it will be into 3. I'll have 3, one for R, one for G, and one for B. Okay, that's exactly what I have converted. This is the entire record with all the pixel values, right? So here it is 100 cross 100 cross 3. So total 30,000. You see there are 30,000 columns. Okay, for every column that record has the pixel value that I have converted into 100 cross 100 cross 3. because I know that I'm dealing with a RGB color photo. Okay, I've taken this. Similarly, I've converted test also, train also, test also, X train, X test, Y train, Y test. Everything has been converted. Okay, this is very important. Preparing the data ready as per your model. Your model will accept particular format of data. As per that, we have to convert the data. Okay, so now we will see this, the shape. Shape is this. Okay, and we have also created the CNN architecture. You guys remember we added a sequential object, and then I added layer, convolution 2D layer, 3x3 filter, and 32 such filters has been added. And padding I have taken, activation ReLU, input shape is this. I have to mention this. Okay, and then max pool, and then again one more convolution with 64 filters, and then max pool, and then finally flatten, and then have a hidden layer with dense connection, that is fully connected architecture, 64 neurons, and then finally one output layer, dense again, which means fully connected from the previous layer. This is dense means fully connected from the previous layer. And why one? Because it's a cat or dog prediction. So only binary class. So only one neuron is enough in the output layer. And since it is a binary class, sigmoid function is taken as activation function. And we have also seen how the parameters are calculated, right? And finally, we will, okay, let me run this. We will also define the hyperparameters, loss function, optimizer, and accuracy. So I'll define this. And in model.fit, I am taking the converted data, np.array xtrain underscore converted. Why am I taking converted, xtrain underscore converted? I cannot take xtrain because xtrain is in the shape of 3000. Xtrain is in the shape of 86 cross 3000, 86 cross 30,000, 30,000. But I want it in the shape of 100 cross 100 cross 3. Okay, that is therefore converted. There are 86 records, each of this dimension, 100 cross 100 cross 3. Okay, so that's why I'm taking this X converted, and I just have to do, when we do fit, we just give X train and Y train, right? That's exactly what I'm giving, X train and Y train. But only thing is I'm giving the converted train and XN converted Y train. And I'm asking to take only those many Y train records, those many, as many as they're in X train, right? Because I have only 86 records, so Y train also should be only 86. It should not be 200 or 10,000. So now if I run this, I'm running only 3 epochs, guys, and batch says it is 32 I've taken. So as you can see, initial first epoch is 62 and then 1 accuracy, which means 100%, 100%, which means the model was clearly overfit. Yes or no? The accuracy on the trained data is 100%. Does it tell that the model is overfit? Yes or no?
Yes, but this is RNN or CNN?
This is CNN. That's what I've been telling from the beginning.
No, no. So RNN, okay. I started with that.
What did you start with?
Fine.
We are dealing with images, and I showed you the images, pixels, and all these. See, this CNN example only. See, I have added convolution, max pooling. So I started with RNN. I told before I begin RNN, let me finish the CNN code also, right?
Okay.
Okay. Yeah. So is this overfit or not overfit? What is your take on this? Anyone?
Overfitting.
Yeah. And can anyone tell me why this CNN model became overfit? Why is this model overfit? It's a very simple answer is straightforward. It's in front of you only actually. Uh, these are all common questions in interviews and also in day-to-day data science life, guys. If you can't tell even this much, then it's a problem. It's overfit, definitely. Why did it become overfit? Think about why don't you think about the reasons any model can become overfit? You guys might have studied in the previous classes, no? Why will linear regression become overfit? Decision tree become overfit? Nobody?
More fluctuation or noise in the training data.
If there is noise, then there is a chance that it will become underfit, right? If there is noise, means there is a lot of variance. True. And if there is a lot of
Yeah.
variance, it will be difficult to capture that.
High bias.
Yeah, that's correct. But why did it
Okay.
happen?
Maybe the training data size is too small,
Yes.
or it has not
What?
enough samples.
Hmm. Hmm. What was the train data size we have taken? 86 images, right?
Yeah.
86 images, just 86 images won't any mod 86 records, think it as 86 records. Won't any model become overfit on just 100 records or 80 records? Definitely, right?
Okay.
But see, think about it like this. I have only these many records. It's easy to come up with such a model like this, right? But if I have so many, let's say over 1 lakh records like this, 1 lakh records, okay? A model to become overfit on 1 lakh records, it's still possible. It is still possible for a model to become overfit, but a model should be something like this, hugely complex, which covers most of the 1 lakh records, right? Now, which one is difficult? To come up with a model which will cover 10 records, or to come up with a model which will cover 1 lakh records, which one is more difficult to find?
The second one.
Yes. To find such an equation or such a curve or such a model which covers all 1 lakh is difficult. So when your records are more and variance is more and records are more, there is less chance of overfit. I'm not telling it will not become overfit. It is less chance. Okay. And when records are less, right, and variance within the data is less. See, this is the variance within the data. And here, this is the variance within the data, right? This is the variance within the data. If you're confused, then you can consider from center also, because variance is measured from center, right? You can see this much is the variance. And if this is the center, the variance is only this much, which means the variance is nothing but spread of the data, right? Variance is spread. How is your data spread across from the center out in general? This is spread more. If it is spread more, it's difficult to capture everything using a single model. So less chance to overfit. The spread is less. Records are also less. Therefore, very high chance of becoming overfit. Quite basic. No matter what, forget about what data you're dealing with. Text data, images data, numerical data, whatever it is. Ultimately, everything will be converted into numbers only. Even though we are dealing with images, we converted into numbers, as you can see here. Ultimately, we deal with numbers only for the model. So that's why it became overfit, because I'm dealing with only 2000, only 86 images. Why am I dealing with only 86 images? Because like I said, this input size is very big. It is taking time for Google Colab to read the entire input size, right? I have over 2000 images. Okay. Let's say I just leave this for about 2 hours and the entire input file is read, and then I have, instead of 86, I have 2000 images available now. Fine. Now, in that case, will it be same overfit as the case when I have only 86 images?
No, it will be hopefully less.
Yeah, correct, exactly. So if you see, if I run this again, now again it is 86 only. It will take some time and then you can see more changes. Anyway, you got the point, right? So Yeah, this is how you build basic CNN model. As you can take more images, size data and everything. We also have MNIST. We also have worked on MNIST data, right? Where we built ANN model. You can also try on that.
Actually, it's okay, fine. It's ANN, right? So that before saying that that ANN, okay, philosophy has to be done. So that's why okay, fine. Basically, same numbers as you said. Okay, got it.
Yeah, no, I didn't get you what you're saying.
See, in case of neural networks, right,
Ah,
the machine learning, when you start thinking that way, that has to be coming out, right? That's okay, fine, no problem. Thanks.
okay. No, what is your doubt or problem? You think I missed something? What is it? Fine. Anyway, let's continue. So, I guys, hopefully, you guys have understood the CNN, guys, architecture, the way CNN works, and then how CNN is better compared to ANN, particularly in case of images. We have seen that, right? What are those? Okay, I just want to test because somebody is also comparing with ANN. What is the disadvantage of ANN when we deal with images? We have discussed all these. And why are we going for this kind of a CNN structure? Okay, at least can you tell me why are we doing pooling in CNN? In CNN, we are doing pooling, right? Either max pooling or mean pooling or average pooling. Why are we doing this?
So reduce the size of the data. And for the question first, sorry, it took some time
Yeah.
to come out of it. What was the first question?
First
Okay, so
question was ANN, what are the drawbacks of ANN on images data?
okay, so it's going to be lateral, like you when you convert into vector, it will be single vector, it will be lateral
Hmm.
reading. So image doesn't work that way.
Yeah. Only it's a linear search basically. CNN, using CNN, we go for spatial level search. Okay. And also this has more weights. We have seen more, it will have more weights compared to CNN. ANN will have more weights. CNN will have lesser weights. It also has more weights. We have seen example, right? We are dealing with 18,000 to 30,000 parameters we are dealing with easily in case of a CNN. But in case of ANN, it will be even more. It will be close to 1 lakh weights that we will be dealing with, or even more. And it doesn't work very well also. So that's again not good enough. Okay. Also, I have shared a couple of images, guys. CNN versus ANN. Right, images I have shared in the WhatsApp group. You can see that whenever you.
Saw that.
Okay, I have kept that. Yeah. Okay. So let's continue with the RNN discussion. Today, not many people have joined. Is it? Is it because of Good Friday? Maybe. Okay.
Yeah. Oh,
Okay.
many have gone for vacation. It's long weekend.
Yeah. Long weekend. Yeah. Correct. Okay, guys. So, RNN, right? Now let's continue. RNN full form, like I said, is recurrent neural network. Okay. Now let's look at some example. So if I say, let's say I will write, um, I went to the shop, ordered vanilla ice cream. It is so good. I am dash it. Okay. So can you guys tell what could be this word? It is simply I went to the shop, ordered vanilla ice cream. It is so good. I am dash it.
Ordering it.
Loving it, ordering it.
Yes, I am loving it. I am liking it. I'm enjoying it. These are the possible words, right? These are the possible words. Obviously, you will not have words such as hating it. This is not at all possible because he already told it is so good. There is no chance this word, there is no very, very, very less probability. Okay, this is more probability, obviously 0.3, 0.2 or 0.65, something like that. Probability will be very, very high, correct? And you can consider that, technically speaking, what are the possible words for this particular blank is, for this place is, what the possible words is, whatever is there in the English vocabulary. There are finite number of words in English vocabulary, right? So for every word, there is a probability that it will be here. But some words will have high probability, some will have low probability, which we are deciding based on what was there before. What was there before, right? So now can you tell me in this case, to tell what is this word, is it a time based prediction or not a time dependency based prediction? Yes or no? What do you guys think? So to predict what is this word, we are definitely seeing what was the previous word and previous word and previous word and previous word. And then when we read all the words one by one, right, to be able to tell what this is. So the first word was this, second, third, fourth, which means at first time T1, T2, T3, T4, T5, T6, T7, and then so on. And then let's say T15. To predict T15, I had to see T14, T12, T10, everything I had to see to guess this appropriately, right? So this is definitely time dependency, right? Without that, how will we be able to predict accurately? Yeah, do you guys agree?
Yeah.
Yes. Okay.
Yes.
Correct. So this is also similar to stock price only. So to predict what is the price on this day, we need to know what is the price that was previous day. Okay, we need to know on the previous day, and then we can compare and we'll come up with some model which will look at all the previous days prices or previous 30 days price and then predict that, hey, this could be 308. Prediction. It could be accurate or not accurate, that's a different thing. But at least to come up and predict something, we need to look at some data. Okay, some past data, which is nothing but this. Similarly for here also. Okay, for here also. Which means you can see that for text data to predict next word prediction. It's a time series based prediction. And then sentiment analysis, let's say. Sentiment analysis, which means there is a review written and you have to tell whether the sentiment is positive or it is negative. Does it depend upon each and every word over here, one by one? Yes. If somebody has written a review of a movie, we have to read each and every word to be tell if the sentiment is positive or negative. So this is also time series dependency.
Manikan, the sentiment analysis is like that smileys kind of thing. Only no,
Which
like
one? Smiley.
yeah. That smileys we get in the WhatsApp kind of thing. That is the sentimental analysis, right? The
No, no.
rating which we give. No, it's
Ah,
not that.
So somebody says, let's say I visited, so okay, sorry. I saw, let's say Bahubali 2 movie. It was fantastic, visuals great, songs enjoyable, um artistic movie, loved it. This is the review somebody has written on, let's say, Book My Show review. Okay. In one word, if you want to tell, hey, I don't want to read all of this. Is it positive? Is the person positive about the movie or negative about the movie? That this is called as sentiment analysis. It could be neutral also. What is
Okay.
his sentiment? What is the person's sentiment about the movie that he has seen? About the movie, he has given a review. What is the sentiment overall? Positive or negative or neutral? That is what is comes under sentiment analysis. Okay.
Yeah,
It,
I
it
got it. Yeah.
yeah, it is there everywhere. Even in Amazon reviews, we can see. We will see somebody will tell about phone camera is good, but battery is bad. Okay, display is good, but a 4K quality is not available. So he is telling one positive, one negative, one positive, one negative. Overall, it will be neutral, something like that. The one example I'm just telling you. Okay. And again here, predict the next word. Okay. Predict the next word is quite common. For example, if you see in Gmail, if you compose something, you will say, please find attach. You'll write, please find attachment of, uh, okay, sorry. Let's say, mm, docs. Then you will automatically get a word prediction, right? Below or above. You will get these words which you click on space, it will be filled, right? In Gmail you can see also, if you write hi, then automatically some words will come. Hope this email finds you well, something like that will automatically come up, right? In a light font. When you click on next arrow, these words will come up automatically, so which means Gmail has some algorithm a model internally which is predicting you have written a word. You have written a word. You have written some words. Based on that, it is predicting what could be the next word. It's giving you a recommendation or suggestion. Instead of you typing, you can just click on the next arrow and then that will be filled automatically. Right? That right? It's there
Yeah, yeah.
everywhere, Outlook and everywhere. It's nothing but next predicting next word based on the previous words. Sentiment analysis, one example. All this is an example of time series dependency. Okay. Also, one more example is videos. Videos. Okay, at timestamp one, this is videos are nothing but mix of many images in a particular sequence, right? So like this T1000, if you want to predict what could be the image, then model will see all the previous images and predict what could be this image, right? So it's again time series based dependency. Okay. So why am I explaining all these in detail with a lot of time is because we should know that in which situations we are using, and we know the situation accordingly. You will understand why RNN was actually built in a particular architecture, right? Because there is a need to capture every previous 10 or previous 20 words or previous 30 words or whatever it is to be able to answer the current word or predict the current word. There is a need to capture that. Accordingly, the architecture is created. Okay. First, we should understand why ANN is not good enough. So first, okay, let's see here. What we will do is, first we have to tell that, hey, the first word is I visited ice cream shop, ordered vanilla ice cream, It was good. Okay. I am predict. I am okay. So this to predict what is the next word. So here I need to predict what is the next word. So like this, I need an architecture. Okay. So these should be connected like this, which means information is getting flowing from this to this to this, and this sequence is important. It should not be in any manner, right? So I am not taking, let's say here there is ice cream, here there is visited, here there is good, okay, here there is ordered. Is this okay if I give the words like this in any random order?
No.
No, meaning is gone. It will not
Yeah.
understand. You will not know the. I can't predict the next word according to probability. You will not know if good is being referred to ice cream or is it being referred to ice cream shop. No, will lead to confusions. Here, good is being referred to ice cream, but if good I put initially here, I totally ignore the sequence and I consider all the words in a random manner. Good could refer to shop, or it could refer to event, whatever it is. In a wrong way, it will represent. So sequence is important. I have to give sequence like this one by one, right? And then here, now the model will predict, okay, that this is enjoying. It will predict, for example. This is the prediction. So this is the kind of um, architecture I need. Okay, and you see here all the previous impact will be there. Previous impact will be there. Okay, so if you look at RNN, once let me add the RNN image also. So this is how RNN looks like. This is the simplest representation of RNN. Okay, but we will see when we expand it based on the time step, this is how it looks like, which means initially there is a neuron. Okay, this is, yeah, here we can see initially there is a neuron. We will give the current input and output will be estimated. And the from the hidden layer, whatever output comes, that will also be passed on to this. And whatever output comes from this hidden layer, that will also be passed on to this. And these are the current words. Current words. Okay. So this is the architecture of this is the diagram flow. We can call it as architecture or flow diagram of RNN. Okay. So let me go more in detail and explain about this architecture. Okay. And by the way, so far clear? Is it clear, guys, or any doubts, confusion so far?
Yeah, clear.
Okay. Okay. Good.
Uh, Okay, so Mani, one quick check. So when we're talking
Yeah,
about say prediction of stock price, we are dealing with
mm,
numbers as T1 data or T2 data.
correct,
And we are
correct.
talking when you're talking about text, we are obviously we are dealing with text as T1 data and T2 data. Now,
Yes, words. Yeah.
words. So okay, numbers are easy. Okay, when I say numbers don't have that much of context, words have too much of context, overloading.
Mm,
Let me say.
mm,
So
mm.
how that will be dealing with it?
No, for models, everything will be in numbers only.
Okay.
Input will be has to be in numbers. So you may be dealing with images, or you may be dealing with text,
Mhm.
right? Or you may be dealing with tabular data
Right.
having numbers and some text, whatever. Ultimately, you convert everything into numbers only, right?
Okay.
This also
Okay.
you will have to convert into numbers.
Okay.
Image, yeah. Because we know models are basically internally nothing but lots of equations only. Okay, because linear regression is an equation. Even neural network is a composite function within a function, sort of an equation. Our equations will work only on numbers. Anything, any mathematics internally will be only on numbers. It cannot be, mathematics cannot be on text or images, right? So
Correct.
that's why like this. Okay. So we will see. First, we will understand the architecture and why we are constructing the architecture like that. Then we will see about converting to numerical also. Okay, otherwise we can see it now itself. So first, let's say I have reviews. Just very small example we will take. Small data set, small example, but more understanding in the uh, architecture side. Okay. So let's say movie was great. Movie is bad. Movie is not good. Something like this we can take. Okay. Obviously, this sentiment is positive. Positive means 1. This sentiment is 0. This sentiment is 0. 0 means negative. Okay. Now, if you see, let us say I have the total vocabulary as this only possible, just for the sake of discussion. So make it things simple. Movie is good, bad, not. Total 5 words are there. Okay. When there are 5 words, then each word I can represent using particular, each word I can represent using uh, a particular numerical representation using one hot encoding, let us say, just to keep it simple. Bad, one hot encoding, not. So this one I can represent as 10000 just for numerical representation. Okay, great. So now we have converted words into numerical representation. Okay, fine. So as per this, if I have a neural network input layer, I would be having 5 neurons here. 5 neurons, because each word, if I need to pass, let's say I need to pass this sentence to this particular neural network architecture, which will have to tell me the sentiment. It will have to predict sentiment. Okay. I already have the actual sentiment values with me. Now I have to send this sentence to the neural network architecture, and that has to predict the sentiment for me. Okay, it has to predict. So I need to send movie is good. These 3 words I need to send. But movie is the first word. So that will be part of the first input layer. But that is movie is represented using 5 numbers like this. Therefore, I kept 5 neurons. Right. So which means for movie it will be 1 0 0 0 0 because the first word is movie. Okay. And then followed by this, I'll have a hidden layer, of course. Hidden layer. And then I will have an output layer. I'll have output layer. Y hat. Okay. Hidden layer, let us say we will take 3 neurons. 3 neurons. Okay. So here I will have connections. Let me just put the connections. Oh, okay. Okay, great. Now the connections, how many are here? 5 cross 3. 15 connections. If you add a bias, then you will have 16 connections, let's say. Okay, or 16 or 3, whatever it is. Let's just do without bias first. Okay. Now what would happen is there would be a feedback loop. We call it as feedback loop of this hidden layer to itself. Of this hidden layer to itself in a time step level. In a time step level. Okay. So how do I put this is now there, see here, there is a connection between this layer and this layer, right? There's a connection between this layer and this layer. And if I want to draw a connection between this layer and this layer, I will have to simply do this. Okay. Now I'm saying there is a feedback loop from this layer to this layer itself, which means there is a connection of this hidden layer to itself. This hidden layer is connected to itself. Okay. So if I do it diagrammatically, it will look something like this. So which means this is connected to itself. This is connected to this, and this is connected to this. Also, this is connected to itself. This is connected to this, and this is connected to this. Also, this is connected to itself. This is connected to this, and this is connected to this, because they're fully connected, right? Fully connected. See, instead of having 1, 2, 3, let me draw it. Like this. Instead of having like this, I'm saying there is no two hidden layer. There is only one hidden layer, which is connected to itself uh, in with respect to timestamp. So there is only one thing, which means 3 here, 3 cross 3, right? Here also 3 is there in the previous time, and in the next time again 3 will be there in this hidden layer. So it will be like this, connected. Okay, it may look very different, but you will understand it with more examples as I tell. Okay, so this is how the connection is, and then followed by that normal connection. This is anyway there. Okay, this is anyway there. Okay, but why are we having such a thing? Why are we having such a thing is when I actually try to simplify this and further expand, you will understand that this is the regular representation, guys. See, one thing is because we do not know how many words are there. So you may ask, hey, why are you doing all this? Why can't I simply take an input, a hidden layer, and an output layer? Because here I will give movie, and then here I will give was or is, here I will give good. And then this will predict whether the sentiment is positive or sentiment is negative. But we do not know that a review will consist of only 3 words, right? We do
Yes.
not know movie will consist of how many words. And here again, the cumulative effect is not taken into account, right? It will be, but not in a very good manner. So ANN architecture will not work well. ANN will work when we know that we can take these many hidden layers, right? We do not know that. Okay. So now if you look at this, let me take this again and okay. So if I just try to expand this, see, consider what happens one by one. Okay, so here let's say the first word is movie. Okay, from movie, you will this is represented as 10000, whatever it is, nothing but movie. And then it will go through these connections and this hidden layer, and you will get a certain output, right? From this neuron, and this neuron, you will get an output. That is again considered and given to, this is time step 2, this is time step 1, let's say. Okay, this is again given to this. I'm just drawing it so that it will be easy for you guys to understand. Okay, apart from this, the next um, also will be considered. Next word. What is the next word? Is. Okay, this will also be passed to this particular hidden layer, right? Because there is only one hidden layer. It is this one only. When we expand it with respect to time, it will look like this. When we expand it with respect to time, it will look like this.
Can you just do
Huh?
it once more? This one, can you just repeat, please?
Yeah, I will repeat. Yeah. So I am saying this first word is movie, which is represented in this numerical form. It will go to this hidden layer with some weights and connections, and you will get certain output from each neuron, right? That will again be passed. This will be passed to the same hidden layer only, actually. That's why there is a feedback loop, right? But if you want to expand it, this is the first time step. This is the second time step. Second time step means when we're dealing with second word. So neural network has to see each and every word, right? It has to see this word, this word, this word, and then predict. So it has to see each word, and then it has to see that this is the first word, this is the second word, this is the third word, and then predict what is there in the output, right? So it should not predict only by looking at the last word. It should also see this, and also combined effect of this and everything. It should be seeing it. That is why we have this kind of an architecture where just continue to listen. With more examples, you will understand. So first word is passed here, and then I have the hidden layer. Okay, and then there will be some output coming from the hidden layer that is again passed on to this hidden layer again. In the next time step, the next word is movie. The next word is is. Okay, this is passed. So now what is happening is, look at this. When when the RNN is learning, and it is learning, it has seen this word, and currently it is seeing this word. Currently it is seeing this word, and with this word, it has come up with some understanding through this hidden layer. It will come out with some output from the hidden layer. But it is not understanding only the current word. It is getting understanding from the previous word also. But previous word you should not give directly like this. Previous word has been passed to the hidden layer, and we got some meaning out of the hidden layer, right? That is also given to this hidden layer in the second time step. Okay, along with the current word, right? Which means the RNN is looking at the current word and trying to make sense of it while considering the previous word also. Similarly, RNN is looking at this word called good and trying to make sense of it, also considering the previous words and making sense of it. Because good, what is good? Ice cream? Is it chocolate? By having the previous word into the picture in the architecture, it will understand that movie is what is referred to as good. But that has to be taken into account, right? That's exactly what is happening. So let us say the third time step, T3, T1, T2, T3. T3 is what? Good. If the RNN learns only the word good, it is not having any context, right? It has to have the previous words also taken into account. So look at this now. Now let's continue. We will take for the next time step, T3. Good. Okay. Good is represented as some, okay, this is one only. 0, 0, 1, 0, 0. Okay, the RNN has to understand the word called good. And I am at time step 3. I'm just making this diagram like this just for the sake of understanding. Okay. T3. And it is a correct way to draw the diagram also. How many neurons I have in the hidden layer? This hidden layer at time step 3. Okay, this is hidden layer. The same hidden layer, same neurons. Okay, obviously this will be there. The current word is being understood. Okay, but I should also take the previous words understanding into account. Where was that happened, or where did that happen? In the time step 2. In the time step 2, the second word understanding was captured. Also, the first word's understanding was captured, which means in the time step 2, there is a combination of first word and second word understanding available. Okay, so that exactly will be also passed on to the time step 3, like this. Yeah, because that also has to be understood by the model, right? Otherwise, model will not know. Yeah, good is being understood, but what is good context is not there. If I pass the previous words also to this hidden layer, okay, through connections, information is passed, then whatever output I get from this hidden layer will be more understood, will be more into with respect to context. Right now, finally, there will be, I think I have to move this around a bit. 3 words are there, right? Let's say, okay, this much. Okay, fine. Now I have output layer. So this connections will be normal. And then the prediction will be positive. Positive. This is how model would function. This is how the architecture will be. Okay, now we don't have to draw everything like this. If there are 10 words, can you imagine, guys? Can you imagine 10 words? You will have T4, T5, T6, T10 until T10 here like this. Connections happening like this. Can you imagine?
Yeah, yeah.
Yes. So why to draw like this? Instead of drawing like this, the same hidden layer, time step 1, time step 2, time step 3, time step 10, just have one input layer, have hidden layer, have output layer, until this hidden layer is connected to itself. It's called feed. Since it is connected to itself, it's called as feedback loop. Feedback loop. With respect to time. 1, 2, 3, 4, 5. 1, 2, 3, 1. You can say like this. Or the even more simpler representation will be this, like this. You can call it like this. See, you can represent like this for detailed understanding. But every time we can't draw that much, right? So what we will do is we will have x1, okay, and this from this you will get output 1. This is hidden layer. Okay, and you will have output from the hidden layer will be passed on to the next time step. In the next time step, you will have x2. Okay, and from this hidden, and you will get an output. You will always get an output. What is this output? It's simply this hidden layer, what you get out of this hidden layer, right? That's nothing but the output. You can display it if you want, or you need not display it. You can just straight away forward it to that hidden layer output, you forward it to the next time step, where the next time step, the input will be x3. And next time step input will be x4. Next time step input will be x5. Next word, next word, next word. But along with that, the previous hidden layer output will also be passed. Previous hidden layer, same hidden layer. Previous time step hidden layer output will be passed. Okay, T1, T2, T3, T4, T5. Finally, at this stage, let us say you will be displaying the final output. Okay, after seeing the fifth word. So maybe in your case, only 5 words are there. Okay, this can be again represented in a single representation, um, very shortest representation. Where is it? Yeah, like this. See, this is exactly what I have written here, right? But I have taken 5 time steps. But there is no guarantee there will be only 5 words in a sentence, right? Or there will be only 5 images in a video. Nothing like that. So let me take it till xn, xn, tn. So that I can simply draw it that there will be a hidden layer, only one hidden layer, right? And it tells its information to itself, right? While there will be an input being passed. There will be an input being passed, right, to all of this hidden layer. To the hidden layer, the current input will be passed, and to that hidden layer, the previous time step hidden layer's output will also be passed, right? Also, this would give me the y, which is nothing but the output layer. So this is the input layer. This is the output layer. This is the hidden layer represented in a very shortest form, right? When we expand this is with respect to time. When we expand this, obviously, if there are 5 time steps, then it'll have like this. 10 time steps, you'll have more. But we don't know how many time steps will be there because we don't know how many words can be there in a sentence. Therefore, we will represent it like this to have a clear understanding. This is the shortest representation of RNN. Okay.
Yeah, like you mean to say, like instead of representing it in the picture, like a bigger one, we are
Yes.
representing it in this
Correct.
feedback loop,
Exactly.
which
Exactly.
means
See.
all the words, previous words will be considered
Yes,
again and
again, again,
again.
again.
Oh,
Yes. So let's say you're at time step number 4. Time step number 4, which means fourth word is given as input to this hidden layer because that's what I told, right? Fourth, see, the fourth, sorry, the fourth word is given as input to this hidden layer. It will be passed to this hidden layer. But there is also a feedback coming from the third time step hidden layer. Like we have seen here from here, third time step hidden layer. Okay, that's exactly what is represented here also. At time step 4, fourth word will be given, and that is to this hidden layer, the one connection is from the input layer, fourth word. Another connection is from the previous step hidden layer, right? Which is again connected, which is again coming from second step hidden layer, which is again coming from first, and then so on. So all that will be taken into account as you can see in this diagram like this. one by one. When you think and expand it, it'll look like that. Okay, but to represent short form, you represent like this. And why are we doing all this? Because we have to do all this because we know that to predict next word, each and every word we have to see before. Or to predict sentiment, we have to see each and every word. Then we can predict. So it's a time dependency. Okay, right? Fine. Is it clear, guys? Any questions, doubts here?
In the diagram you were showing me, I was seeing time t+1 and t-1. How that can be?
Where is t minus 1? In
The
which
diagram
diagram? This
yeah.
diagram?
No, that you took that
Huh.
from net, right?
Huh.
Yeah, this one.
Yeah, it's just anything. It's you take it as t, you take it as t+1, t+2. He's taken it as t minus 2, t minus 1, t. It's in sequence only, right?
Okay.
So no problem. You just if you take this as t, it will be t minus 1, t minus 2. He's telling that at this level, the previous time steps will be impacting, and this will be impacting the next time steps. That's the representation. That's it.
Okay.
Okay. So yeah, I hope you understood the nature or philosophy of RNN. CNN has a particular way or philosophy of understanding images, filter search in a spatial manner. RNN sequential, it has to be. That is time series based. It has to be. Okay. So we understood that with example, and we understood the architecture also. Okay. If you guys understood this, it is good enough. See, I want to go to forward propagation and backward propagation now, but if I do all derivations and all, it may get too much and too confusing. So I will not go, and not many people are there also in today's class, right? Only 6 people are there. So I don't want to go to this important concept called backward propagation in RNN. It's very, very important. We have something called vanishing gradient, exploding gradient to understand as a concept. So that is perfect when we understand with RNN. Okay. So I will not go start that now. I'll start it on Monday's class. Now I'll just stop, guys. Now I'll just stop for now. Uh, I'm done with today's class because we have seen quite a bit. So I just want to see if there are any questions, any doubts, you can ask me, guys. Okay, okay, good, good. Can anyone give me the Google folder drive link, guys? Google Drive link. I'll just put this collab files and notes and everything I'll upload. Okay, no, I will again check in. Okay, thank you, Ishak. I will upload this notes and the code files. Yeah, this is
Okay.
the one. This is the one. Right. So I will upload this after I end the class. And mm, okay, so any other questions, any other doubts? What else from whatever you're learning so far? You guys have a test, is it? I've seen something in the WhatsApp group, some exam, some
Yeah,
quiz.
tomorrow, like it is
Okay,
the certification for this
okay,
course.
okay. Is it what all topics are there?
Yeah, everything is there. Like right from the beginning, we had a Python, Stats
Hmm,
ML,
hmm.
this SQL, deep learning, till deep learning it is there.
Okay, okay. But we are not finished the complete deep learning, right? There
Yeah,
are
yeah,
still
yeah,
to talk.
yeah, yeah. So even we were talking about that only, but we don't know like what type of questions
Fine,
we'll get on that.
fine. Yeah. I'll again and anyway inform them that only these topics are then, so that at least they will do some changes,
Yeah, 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 yeah,
hopefully.
yeah, yeah. Right.
Sure, sure. Okay, so please prepare well, guys, everyone, and all the best for your exam. It will be very simple. Trust me, you just stick to basics, understand everything with basic level. If you're getting confused in the questions, take example and then try to reach the solution. Always take examples. Very basic level thinking you can maintain. I think in deep learning, they will ask you if these are the epochs, these are the batch size, how many iterations will you will be performed, how many times weight will be updated, and some optimization algorithms they might ask, activation functions they might ask. That's very basic in deep learning. So anything in deep learning, I'm sure you should get at least 60-70% minimum without preparation also. But
Yes.
prepare well, you will get even more.
Yeah, sure, sure. Thank you.
Okay, great. Okay, guys, that's all then. Thank you, guys, everyone. Have a nice weekend. All the best for the quiz and a nice weekend, guys. Take care. Bye, everyone. Bye, guys.